And hello, Elias. So here's the questions on your screen. Please practice this one. Do this one.
Okay. Okay, sir.
Practice this one. When you're done, please let me know, okay?
Okay, sir.
You done this one?
No, sir. I'm still done.
Good. Okay, after doing this one, you have to do this one also.
Okay, sir.
So what is this given to you? W by W?
Yes, sir.
Equation. What is being asked? Capital M is being asked. Molarity.
Yes, sir.
If the density is given to you, you have direct formula
Yes,
for this one. You can check in your copy.
yes, sir. Almost done, sir. I'm just in the last. I'm just multiplying. Sir, the answer is 16.24.
16.24. Okay, let me will check it. First do this one. Do the next one.
Okay, sir.
16.24, na?
Yes, sir.
Molarity of the solution. Okay, we'll check it. Yeah, your answer is correct, Thameem. Your answer is correct for
Okay,
the
sir.
first question. Okay. Good. You done this one?
No, sir.
Should I help you? Are you still doing
Sure,
it?
sir.
Okay.
I'm stuck here.
Okay. What is saying here? If it is given to you that the how many milliliters of SCl is required to react. So what it is asking? It is asking volume. Okay, ml. And molarity is given to you. That is M1 is given to you 0.01 required to react completely 1 gram of, okay, it is in molarity. And if react completely with 1 gram of mixtures of Na2CO3 and sodium hydrogen HNO3 containing equimolar amount of both, means both are going to have equal. Equimolar means they are going to have 1 mole. Okay, got it? Of both.
Yes, sir.
So you know that if I'm having 1 gram, there is a mixture and that is containing how many millimoles of 0.03 acyls is being required to react completely 1 grams of Na2CO3, okay, and NaCO3 containing equimolars, mean both are containing equimolar of this one. So for example, if I'm having SCl, like I'm writing Na2CO3, CO3, okay, when react with SCl, what it will gives you? It will gives you sodium chloride plus,
Yes, sir.
tell me, plus water plus carbon dioxide. Okay, you balance this one. Try to balance this one first.
Mm.
You will get 2 here. Okay, 2 NaCl, and here what is the amount of here? You will get NaCl2. Okay, there are 2 chloride atoms, so you have to multiply here chlorine, and here is only single atom, so you have to multiply this one too. Okay, got it? So now it
Yes,
is
sir.
balanced. So we'll simply say that the 2 nitrogen, 2 chlorine, 2 hydrogen here, 1 carbon, oxygen is 3, oxygen is 3. Okay, now it is balanced. So we'll say
So,
that
do I
here,
have class right now?
no, you don't have. Means you might have, but you are on the incorrect link. Okay, try to the Learnivio team. They will text ask you
Okay,
what
sir, thank you.
Now moving to the next part here is that the ratio of combining acid here is 1:2. Got it?
Yes, sir.
Got it? Means
Yes, sir.
one Na2CO3, one Na2CO3 is going to react with 2 molecule of acid. For example, 1 mole of this one, okay, will react with 2 mole of this one. Got it?
Yes, sir.
Got it?
Yes, sir.
Okay. So what is the mass of this one? What is the mass of this one?
So it's what? Na2CO3.
Yeah, calculate the mass.
Um, it's 106.
106.
6.
Okay, 106. And here it will be 35, 36.5. So for the two, it will be 36 to the 72. Okay, 72, 73. Got it?
Yes,
Got
sir.
it? Now, for example, if you are having this one, NaHCO3, NaHCO3, okay, and you are reacting this HCl, what you will get? What you will get? You will get same,
Um,
whether it's metal carbonate or metal hydrogen carbonate, they are going to react together. Okay, they are going to form salt plus metal plus carbon dioxide. Okay, but here the ratio of combined ratio is 1:1. Okay, you balance it is already balanced. Two hydrogen, one Na, one Cl, one Cl. So it is already balanced. Okay, you understood?
yes, sir.
Got it? Now it is
Yes, sir.
zero. Now it is zero. It is 36.5. 36.5 is reacting with how much? Sodium is 23. Okay, carbon is 12, and hydrogen and for 16, 3 the 48, and 1 14 9. You add it all, you will get 2 5 5 and 9 14, 1 carry, and then 2 and 1 3, 3 and 1. Okay, it is how much it is? 2 plus 3 4 and 14. Yes, 1 3 3 and 1 4, 4 and 4 8, 84 mass. Okay, so it is 84 gram is reacting with this one. Got it? Got it?
Yes, sir.
And here
Yes, sir.
176. Okay, now according to, we will simply say that if it is saying that we are going to react equimolar. Okay, so it is saying that equimolar, how many ml of 0.m SCLs is required to react completely with 1 gram of mixtures of Na2CO3 and sodium hydrogen carbonate. Okay, containing equimolar amount of both. They are both equimolar. Okay, they are equivalent, or we should, they are just equal in number of moles. Okay, so if I'm saying that if 1 mole of this one is present and 1 mole of this one, both are going to have, you know that, so for that 2 HCl is required, and here for example 1 mole of this one is present, 1 mole of this one is present. So how many total moles of HCl will be required? Tell me. 3 moles. For example,
yes,
one
sir.
mole of one mole, because there is one in a one. So if 1 mole of this one is present and 1 mole of this one is present, they both are one mole. So for this to react completely, we required 2 moles. And here for this, we required how much? 1 mole. So total, the ratio of combining ratio means for reacting 1 mole and 1 mole this one completely and 1 mole this one, we required 3 moles of HCl. Are you getting my point?
Yes, sir.
2, because you know that here simply that 2 moles of HCl will be required to react completely 1 mole of Na2CO3. And simply here also, if I'm saying that HCl, here it is, since it is already balanced, so it is the ratio of HCl and combining ratio with this one is 1:1. So we'll simply say that 1 mole of HCl will react with 1 mole of sodium hydrogen carbonate. Got it? So for
Yes, sir.
every one mole of this one, okay, okay, one mole of this one will require 3 moles of. So if I ask you the total amount of this one, what is the total amount of this one? Tell me. Total amount. We required 1 mole this one mole this one. So total amount of this one is 106 plus 84. How
106.
much it will be? 190.
Yes, sir.
Okay. So for 190, if I'm saying 190 gram of substance, we require how much amount of HCl? 35.5, 36.5 plus 73. Okay, 3 moles. Okay, because 2 moles of HCl is going to have 36.5, and you multiplied by 2, you will get 73. Okay, got it? So
Yes, sir.
how much amount of HCl will be required? 73.0 plus 36.5. 36.5. We'll get 0.5, and this one is okay. This one is 39, and this one is 10. So that you are going to have is 109.5. Okay,
Yes,
109.5. Got it?
yes, sir.
Okay. Now for 190 gram, we require this much. Okay, this much for now 190 gram of substance. Okay, got it? And
Yes, sir.
if it is 1 gram, because 1 mole of this one, 1 mole of this one, if it is 1 gram, so how much grams of substance will be required? If it is 1 gram, it is saying it is 1 gram. Okay, completely required to react 1 gram of mixture of this ones, containing both equimolar of this one. Okay, so 190 gram. Just I'm just confirming here that 190 gram of solution is going to have 1 mole of this one and 1 mole of NaHCO3 and 1 mole of Na2CO3. You understood? They both are 1
Yes,
mole.
sir.
So it is not saying 190. So for 190 gram, we require this much amount of HCl. So for 1 gram, how much amount of HCl will be required? 109.5 divided by 190. Okay, got it?
Yes, sir.
So this will gives you the gram. This will gives you the gram. Okay, this amount of HCl is being required. But it is saying in the question, that how many ml of HCl will be required, but it is in gram. Okay, of 0.1 mole HCl means 0.1 mole means, just concentrate here, that now molarity is given to you. That is, what is molarity? Molarity is equals to number of moles of solute present in 1 liter of solution, per liter of solution. Okay, present
Yes, sir.
per liter of solution. Okay, so if I'm saying that molarity is 0.1, so it means 0.1 mole is present in 1 liter of solution.
Yes, sir.
Are you getting? Per liter of solution.
Yes,
Or we can say that per ml of solution. And you know that HCl, and because the solution is 0.1 mole, so we can say here that number of moles of solute will be equals to per liter of solution. How many ml? So it means that 0.1 mole of HCl is present in 1 liter of solution. Okay, 0.1 molarity of solution means that 0.1 mole of HCl is present. Sorry, 0.1 mole of HCl is present in how many liter of solution? In 1 liter of solution. You understood?
yes, sir.
Okay. Now it is asking for the ml. So if I just converting this one, number of moles. Okay, first you need to calculate the number of moles, and number of moles is given mass upon molar mass, and that is 0.01 mole. Okay, and here it is saying equimolar. Okay, the both are in both amount. So you have to divide this one, that for every 1 liter of solution there is only 1 mole present. So that is for 1 gram. You have to, now this will be in grams. Okay, so you divide this one, you will get how much? That is 109.5 divided by 190. You will get how much? You will get 0 point. You will remove this decimal. You will get 0.95 divided by 190. You remove this one, it is approximately 200. Just assuming. I'm just getting my approximation answer. Okay, got it?
Yes, sir.
So just assume that it is 200. Such I'm just getting an answer. Okay, and this is 10990. That's because we are just increasing this one, so we are just decreasing this one. And this is approximately 1095. Let's just assume that it is 1000. Okay, 000. Got it? So
Yes.
approximately your answer is nearer to 4 point something. Got it? But 4 point something is okay, but it is saying that 1 gram of mixture is containing with 0.1 mole of HCl. Means now you need to understood that your solution means the number of moles that you actually required. Just concentrate here. This is important. This is very important that you need to concentrate here one more time. That for example, you have total amount is 5. That your answer is you got 5 grams. Okay, your answer is 5. Okay, what you get here? For 190, when you divide it, you will get approximate 4 point something or approximate. Just need to understood the concept of the question. Okay, now it is 5 grams. Approximate answer that 5 grams of HCl. 5 grams of HCl will be required to completely react with, tell me, to completely react with 1 mole of 1 mole of Na2CO3 and
Yes, sir.
1 mole of NaHCO3 and having 1 gram. The total are having means they are equimolar. They both are equimoles and that is total amount is 1 gram. Got it?
Yes, sir.
Got it. Now one thing you need to note it down that this is the 5 grams of HCl when it is present. That is the 5 is the purest amount of HCl. Now, if I told you, if I say you the solution, the molarity of the solution, molarity of solution is 1 m. So what does it mean? That 36.5 gram of HCl is present in 1 liter of solution. You understood? You understood?
Yes, sir.
Just let me explain you that, for example, you went to a market. Okay, you went to market to buy some bananas. Okay, you went to the market to buy some bananas. And if I'm saying that in that bananas there are, means all the bananas are in good quality. Okay, all the bananas are in good quality and you want to buy 12 bananas. So how many bananas will you actually buy to get good quality? You
12.
will exactly 12. But if I'm
Yes,
saying
sir.
that the ratio of the good banana and the rotten bananas is for every 3 bananas, there are 2 rotten bananas and 1 good banana. And you need 12 bananas. So how many actually banana you will buy total?
Yes, sir.
How many banana you will buy? For example, I'm saying that for every 3 bananas, there are
Yes, sir.
1 good banana, only 1 good banana, and other 2 are means they are not, they are rotten. Okay. So if I ask you that you need to buy 12 bananas, so how many bananas you will buy in total?
Um,
36.
yes, sir.
Because out of 36, 12 will be good and 24 will be means rotten. Okay. And you need the good
Yes.
bananas. So similarly, if I'm saying the molarity of the solution is 1 m. Okay. So it means that 36 grams of HCl is present in 1 liter of solution. Okay. And if I'm saying the molarity of the solution, molarity means molarity of solution is 0.1 m. Okay. So it means that only 3.65 gram of HCl will be required or sorry is 3.6 grams of HCl is present is present in 1 liter of solution.
Yes,
1
sir.
liter of solution. Okay, got it? 1 liter of solution with of HCl. Okay. So if I ask you that you required approximately 4 point something or approximately 5, let's suppose you require 5 gram of HCl, total 5 gram of HCl. And for every 1 liter, you have this much amount of HCl because it is this HCl contain the molarity of the solution is 0. 1. So it means that for every 1 liter of solution, only this much amount of HCl is present. Are you getting my point? What if I'm saying that
Yes.
the molarity of the solution is 0.1? So it means that number of moles of solution upon volume of solution. Okay, so if I say that number of moles is that grams is 3.65, and that number of moles, this is the given mass upon molar mass is 36.5 upon 1 liter. Okay, you cancel this one, you will get 0.1 or 1 upon 10. Okay, so it means that 0.1 mole, 0.1 mole means 3.65 gram. Okay, what I'm saying, you need to concentrate the concept. If the concept is clear, then everything is clear. Okay, so what I'm saying here is that 0.1 mole of HCl solution means that 3.6 gram of HCl is present in 1 liter of solution. If I'm saying 1 m solution, 1 m, it means that 1 mole of HCl, 1 mole of HCl weight 36.5. If I'm saying the molarity of the solution is 2m, so it means 2 mole of HCl is present in 1 liter of solution. So it means that if you have 1 liter of solution, then the amount of HCl in that will be 2 into 36.5. Are you getting my point?
Yes, sir.
Okay. So in simple, if I'm having the molarity of the solution is 0.1, now if you need a total amount of 5, and in 1 liter of solution, you have this much amount. So this is very simple. Now 1 liter, yani 1 liter means, or 1000 ml, 1000 ml of solution have 36.5, 3.65 gram of HCl. And how much amount of HCl you required? You required 5. So I can write it like this way: 3.65 gram of HCl has 1000 ml, means is present in 1000 ml. This amount of HCl is present in 1. So you will say that 1 gram of HCl will be present in 1000 divided by 3.65. Okay, got it? Now you can do the actual calculation here, that we have assumed the 5 for divide this 109.5 by 190 with the help of calculator. You can do it. Do it, please. What value you will get? 109.5 divided by
Zero
109.5
point
divided by how much?
0.97 5 no, wait. Oh, I put the wrong. So
109 point
0.576.
0.576. Okay, 109.5 divided by 190.
Yes, sir.
Okay, means actually 0.57 grams. Okay, so if I'm saying yeah, 190, where it is, where is the question? Okay, okay, so 1 gram of this one will be required, this amount of HCl. Okay, this ml of HCl, this ml of HCl solution. So if you required 0.576, so how much amount will be required? You will get 1000 into 3.65 into 0.576. This much amount of HCl will be required.
Yes, sir.
I'm going to explain you this one more time in a fast go. You first multiply this one, then I'm going to explain. Multiply this one.
Okay, sir.
576 divided by 3.65 ml. Because when you multiply with 1000, you will get this one multiplied. Okay.
Yes, sir.
Note it down. Noted.
I'm noting it down.
What's the answer? You multiplied?
No, sir, I'm still doing. So it's 15.7.
15 point.
7.
No, it should be greater. It should be greater. You are dividing this number by 3. Means this is approximately 3.5 or 4, approximate 4. If you even divide this number by 4, you will get more than 100 something. It is when you multiply this number, you will get the decimal shifted to 3 digit. You will get
This
576.
it's
570,
157, so it's 157.8.
157 0.8. Okay. So let me explain you in one go. Let me explain you in one go. What is saying in the question? What is saying in the question? That here it is given to you that it is asking volume of SCl. What is it? How many ml of SCl is required or are required to react 1 gram of mixtures which is containing this one and this one in equimolar amount. Mean equimolar means they both are having 1 mole or 2 mole, 3 mole or 4 mole. Mean both are going to have the equal amount. Okay, got it?
Yes, sir.
So the simplest ratio, if we balance this equation, we get Na2CO3 when react with what SCl. Okay, then it will gives you this reaction. And here you will notice that when you balance this one, the ratio, the combining ratio of HCl, 1 mole with this one is 2 molecule of HCl, means 2 mole. If 1 mole of this one is present, then we have 2 mole of HCl. You understood?
Yes, sir.
When you are balancing this one, then there will be 2 moles. So for if it is 1 mole of this one is present, then we require 2 mole of HCl. Got it?
Yes,
Got
sir.
it? Similarly,
Yes, sir.
similarly, if we have sodium hydrogen carbonate, when react with HCl, it is balanced and it will gives you this one, this reaction. Here we have 1 mole of this one, required only 1 mole. Unlike this one, it was reacting with 2 mole. Here it is only 1 mole of HCl is required. Okay. So for example, if you have 1 mole with this one and 1 mole with this one, both equimolar means both are having 1 mole. We are just having same amount, same mole. Equimolar means they must have same number of moles. So if in the simplest, if 1 mole of this one is present and 1 mole of this one is present, then in total, we will require 3 moles of HCl. We will require 3 moles of HCl, yes or no? 2 mole for
Yes,
this
sir.
one and 1 mole for this one, 3 mole of HCl. Okay. And the total weight of this one would be, you will add up these two, you will get 190. Got it? So in simple and short, we can say that for every 190 grams of solution, which is containing 1 mole of this one and 1 mole of this one, we will require 36.5 for this one and 73 for the above one. In total, we will have 109.5 grams of HCl. Grams of HCl. Means for every 190 grams of 190 grams of the mixture of sodium hydrogen carbonate and sodium carbonate, we required how much grams of HCl? Tell me fast. 109.5 grams of HCl. You understood? Yes or no?
Yes, sir.
Okay. Now, if you have 190 this one, you require this one, this much amount. If I ask you that in simple, you are not going to have this one 190, you have only 1 gram of this one. So how much amount of HCl will be required? The ratio. If for 190 gram, this require this one. So for 1 gram, this 90 will comes down. You will get this much amount of 0.57 grams of HCl. You understood?
Yes, sir.
Understood?
Yes, sir.
Okay. Now, your solution, the solution which you are having, you are actually having this, you exactly need this amount of HCl. Okay. This grams of HCl. But you need to find out that your solution, which is containing HCl, that is of 0.1 molarity. 0.1 molarity. It means that 0.1 mole is present per liter of solution. Okay. If you have 1 liter of solution, means 1000 ml of solution, then in that one, only 0.1 mole means 3.65 gram, because 1 mole of HCl has 36.5. So 0.1 mole will have 3.65 grams of HCl. You understood? Yes or no?
Yes, sir.
Okay. This one. Now, what you need to find out? You need to find out that for 100 ml, you require this one, but the exact amount you require this one. So you can write down that 3.65 gram of HCl, okay, is present in 1000 ml. So 1 gram of HCl will be present in 1000 divided by 3.65 gram ml of solution. And but you don't need even 1 gram. You need one less 0.576 gram of HCl. So what you need to do is you need to multiply 0.75 0.76, okay, gram, and you have to multiply this number also by, for this one will require 3.65 into 0.576 grams, and you multiply it, you will get how much amount of ml? You will get 157 or 158 ml of solution approx.
Yes, sir.
You understood? It is a time taking question. I know that it took time, but I will give you extra and will tell the team not to. Okay, consider that one. So
Yes, sir.
let it be. Okay, but you understood the concept now? Yes or no?
Yes, sir.
If I ask you the question for the next day, will you be able to do this one? Practice at least one or
Yes,
two
sir.
times this question. Okay. And when you keep
Okay,
on
sir.
practicing, then you will be able to manage this one. No worry. Okay. So let's move towards the haloalkanes and haloarenes.
Yes, sir.
Okay. What do you mean by haloalkanes and haloarenes? Okay. Let's me talk about this one. This is very important.
So can I copy this first?
That one you have not copied. Okay.
I just did the calculations.
Okay. So do this one if you are going to copy.
Yes, sir.
Is it, are you taking the class with the laptop or mobile
What's that?
phone? You're taking the class with laptop or mobile phone?
Oh, I'm taking her in a tablet, sir.
Tablet should be greater in size now. Okay, try this one.
Yes.
Is it visible to you now?
Yes, sir.
Okay, try this one.
Okay.
When you're done, please let me know. Okay.
Yes, sir. So you can scroll down.
This the same that we have this portion we have done here. Okay. So
Yes,
this
sir.
is the all question that you don't need to scroll down. You done, Thameem? Should I move to the next hello alkanes and halogene?
Almost 1 minute. Done, sir.
Okay, so let's move to the next part here. Hello alkenes and hello arenes. Okay, hello alkenes and hello arenes or arenes. If I'm talking about hello, the word hello means halogen. It comes from the 17 group element and its name means halogen. Okay. Uh,
Yes, sir.
And halogen, what does halogen means? Halogen is the 17 group element. 17th group elements are called halogens. Okay. Like for example, uh, fluorine, chlorine, bromine, iodine. Okay. Got it? And what are
Yes, sir.
alkanes? If I'm talking about alkanes, alkanes are the hydrocarbons having hydrogen and carbon only. Alkanes are the hydrocarbons. Okay. So we'll say that alkanes are the are the hydrocarbons, okay, having having general hydrocarbon means that is only containing hydrogen and carbon only. Having general formula CnH2n plus 2. CnH2n plus 2. Okay. Where n is the number of hydrogen. Number of hydrogen. Sorry, number of carbon atoms. Number of carbon atoms. Okay. So if I simply say here that what are alkanes? So alkanes are the hydrocarbon with which carbon atoms are bonded with single bond. Ane means carbon atom bonded with single bond. Okay. Carbon atom bounded with single bond. Bounded with single bond. With single bond. Okay. Got it?
Yes, sir.
So if the
Yes, sir.
carbon atoms are bonded with single bond, they are going to have alkane. Okay. Now, what is
Yes, sir.
haloalkane? Like for example, if I'm having this SEH4 or C2H6, that if I'm having C2H6, okay, means for example, the structure of this one will be two carbon bonded together like this way, and one hydrogen here, 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 one hydrogen here. So this is alkane. You understood? Because carbon is bonded with single bond, that's why it is an alkane. And the general formula is C2, the two carbon and six hydrogens. Okay. But it is C2S6 when react with chlorine gas, that I'm passing it with chlorine gas in the presence of UV rays. UV rays. Okay. Then this C2S6, one of the hydrogen from this one will be removed. Okay. And will form C2H5. And one of the chlorine atom in place of this one of that hydrogen will get its position and form C2H5. It was HCl. It was from 6. One hydrogen will be removed. It will become C2H5, Cl, and plus one chlorine from this one. Okay, and one chlorine from this one has been attached here, and one hydrogen, the release hydrogen from this one will form HCl. Got it? Now this
Yes,
is
sir.
known as haloalkane. This is known as haloalkane. haloalkane. It is a haloalkane. Why? Because the carbon atom, this is containing carbon, hydrogen, and only halogen. So haloalkane means which is the hydrocarbon chain when it is when one hydrogen is being removed from it, and in that hydrogen, in that place of hydrogen, one halogen atom, either fluorine, chlorine, bromine, or iodine, has attached to it. It's taken its place. Is known as haloalkane. Okay, got it?
Yes, sir.
You understood what is haloalkanes? So haloalkanes, if I am talking on the basis of the classification, there can be different types of haloalkanes: mono, di, poly, halogens. Okay, di, tri, tetra. Okay, depending on whether they contain one, two, or three halogens. Means halogens means if they are containing two halogens. Okay, this is containing only one halogen. XXO. One thing you need to note it down that halogen halogen is represented by X. Is represented halogen group is represented by halogen group is represented by X. Okay. So if it is written C2H5, if it is written C2H5X, X means only one halogen group is there. Okay. Other name it should be C2S6. Means normal alkane is C2S6. But when we added one alkane, one halogen to it, okay, then it will become haloalkanes. Okay. And in place of chlorine, there can we write it X. Why? Because it can be X indicate means it can be fluorine, chlorine, bromine, or iodine, anything. You understood what I'm saying?
Yes, sir.
Okay. Now moving to this one, if suppose if this reaction keep on going, you are keep on passing this one. So what would happen? The C2H5Cl, when it is continuously getting the chlorine, then one more hydrogen will also be removed and it will become C2H4. Now it is Cl2, X2. So you can write it C2H4X2. X2 means two halogens. Two halogen atoms are bonded. Okay. Plus HCl. If it is 3, for example, if you keep on passing C2H5Cl2, if it is Cl2, when you pass further, it will become C2H3Cl3 plus HCl. So you know that here the three chlorine atom, here two chlorine atom, here is one. So if there is one chlorine atom or one halogen atom is present, it is known as mono. If it is 2 is present, it is known as di. If it is 3 is present, it is known as tri. If it is 4 present, it is known as tetra. Okay, you understood? Di, tri, tetra. Got it? So it
Yes,
is
sir.
monohaloalkane, monohaloalkanes. This is dihaloalkane. This is trihaloalkane. So on the basis of this, only draw this one. Only draw this portion. Okay, draw this one.
Yes, sir.
You done?
Yes, sir.
Okay. Now this is mono. Okay. Now moving to the next part here is what is haloarenes? What is haloarenes? What is haloarenes? You know that arenes are generally those compound that is containing benzene ring. Okay. Like for example, this one is containing benzene ring. You know this is benzene ring. Okay. Actually, the shape of this one is it is also containing the hydrogen atom. The formula for benzene is C6S6. C6 C6S6. Okay. Each carbon atom is making three bonds. This is present here carbon. This is one present here carbon. So if I make it like this way, C double bond, C single bond, C double bond, C single bond. Then we have double bond, single bond. Okay. Then 1, 2, 3, 4, 5. Then double bond, C, and then single bond. Okay. So this is just like a benzene ring, okay, which is containing 6 carbon, 1, 2, 3, 4, 5, 6. Okay. And alternate double bonds. You know that one carbon has can combine with four atoms. So at a single time, but here it is making only 3 bonds. So here one hydrogen, one hydrogen, one hydrogen, one hydrogen, one hydrogen, and one hydrogen is atoms is there. Okay. So you can check it. It is 6 carbon and 6 hydrogen. But if I remove one hydrogen from it, and if I add one X atom to it, okay, so it is known as monohaloarenes. Mono means which is containing only one halogen group, and haloarenes. Why it is arene? Because arenes are those compound. Alkanes are those compound that contain a straight chain or branch. Okay, okay, got it. Either there can be straight chain alkane, or it can be branch like this way. Okay, or like in the cycle also. But there must be single bond. Okay, in the cycle, but there must be single bond. But if a compound contain benzene ring, benzene ring, okay, 6C6H6, then it is known as arenes, because benzene containing compounds are known as arenes. You understood? There are other compounds also which do not contain benzene, but all of the compounds that generally have benzene ring are considered to be as arenes. Okay, you understood? Aromatic compounds. Arenes come the word from aromatic, because those compounds that contain benzene ring are known as aromatic compounds. And that type of if that benzene rings in place of hydrogen, if it is containing halogen group like chlorine, bromine, iodine, anything, so it is considered to be as haloarenes. You understood now? Understood?
Yes,
Yes
sir.
or no? So here it is
Yes, sir.
monohaloarenes. Mono means for the single X atom in place of hydrogen. Here if it is not mentioned hydrogen, here are hydrogen. But if in place of hydrogen, if we are writing anything else, hydrogen we don't write. It is understandable. Like for example, 5 upon 1 is 5. We don't write 5 upon 1 every time. We write 2, we write 3. But it is understandable that if it is not having any number in the denominator, it means it is 1. It is understandable. But if it is having 2, 3, some others, for example, if it is 5 by 2, so you have to write mention this one. Similarly, if it is hydrogen, we don't write hydrogen. But if it is in place of hydrogen, if there is any other atom, then we have to mention it. Right? It is any other atom like X, OH, anything. Okay. NO2, anything. Except hydrogen, every other atom is represented in the ring. Got it? So if it is containing 2, it is dihaloarenes. When if it is containing 3, it is known as trihaloarenes. Okay. Got it? Got it?
Yes, sir.
Now moving to
Yes,
the
sir.
next part. Moving to the next part is hybridization. Hybridization is a concept that you have studied in the in the 11th standard. And this is the intermixing of the orbitals when two or more different kinds of orbitals are combining together. Like for example, 1s and 2p orbital, 1s and 2p orbital, they are combining together. So they mix together and they form new hybrid orbital. That is sp3 hybrid, so sp2 hybridized orbital. It will form two new sp. It will form new sp2 hybridized orbital. Okay. Okay.
Yes, sir.
SP2. Have you memorized this one, or means is it getting to you, or you this is out of, means you have forgotten this one? SP2, SP3 hybridization, SP3.
I've yet to revise them again, sir.
You need to revise it again.
Yes.
Okay. Let me explain you why this number. That if the carbon is making all single bonds, like for example, this is carbon, it is making all single bond, then its hybridization, it is making how many single bonds? 3. 4, sorry. So its hybridization will be sp3. Its hybridization will be sp3.
Three.
Okay. Means how many single bonds are there? 4. Number of single bonds? Single bond is 4. So if the number of single bond is 4, then it is hybridization is sp3. Just keep in mind. We will explain you later, because it is not in here. We are just going to start as hybridization, then it will take all the time. So just whatever we required to find out the hybridization, we are just learning that one only. Okay. And if the carbon is making, for example, carbon is bonded with double bond, and now this carbon and can make only 2 bonds here and 2 bonds here. Two single bonds. So if I ask you that how many sigma bond, single bond. So it is single bond, it is single bond, it is sigma, and it is pi. It is double bond. The second bond is known as pi bond. Okay. So how many sigma bond this carbon is making? 1, 2, 3. Single bond is 3. So its number is 3, means single bond is 3, and its hybridization will be sp2. Its hybridization will be sp2. sp2 for the 3. Why? Because 1s and 2p. You will get 1, 2, 3. Total 3. So here 3 sigma bond, it means sp3. Here, sorry, sp2. If it is 4 single bond, it is spp3. Okay, sp3. So means total we will have 4. 1 for this one, 2 for this one, 3 for this one, 4 for this one. 4 single bond means sp3 hybridization. You understood?
Yes,
Got
sir.
it? If a carbon is
Yes.
bonded with triple bond, let's suppose, then it will make 1, 2, 3, 3 single bonds here and 1 single bond. Sorry, 1 sigma bond here and 1 sigma bond here. This is pi double bond. This is also pi bond. So if I ask you that what is the hybridization of this one? So how many single bonds are there? Sigma bonds, sigma bonds. How many sigma bonds? Sigma bond means if it is something is bonded with triple bond, so it means one bond is single, other bonds are pi. They are not counted, only one time. Okay, so how many single bond this carbon is making?
One.
Two. One with this one and one with this one.
Oh, okay.
So if it is two, then what would be the hybridization? It should be two. So S and P only. SP. Understood?
Yes, sir.
So please note it down. Then you will get, you will not stuck. If I explain you when you will go get the question, do it one please. Do this one.
Okay, done.
Okay. So next type of, now you understood the concept of monohaloalkane, dihaloalkane, trihaloalkane, or and similarly monohaloarenes, dihaloarenes, and trihaloarenes. Next type of allylic halides. What is allylic halides? Allylic halides are those halides, okay, in which if if you see this structure, this is allylic halide. You see here, this is carbon, and this hydrogen is bonded with this carbon. So one hydrogen is bonded with this one hydrogen is bonded with this one, and X is also bonded with this carbon. X. Okay. Now you check here that this carbon, here it is no, you know the bond line structure. Let me explain you the bond line structure. For example, if I'm making like this way, this is a compound, but it is mentioned in bond line structure. It is mentioned in bond line. So in this, we don't mention the carbon and hydrogen. Other element is mentioned here. Mentioned if, okay, it is a straight line and other elements are going to mention here. For example, let you concentrate here. For example, what is this? This is carbon here, one carbon here, one carbon here, one carbon. So it is a 4 carbon chain. 4 carbon chain. Okay. And hydrogen we will because we don't write carbon and hydrogen only. Other elements are mentioned. If it is there, it is mentioned. So if I wrote it like this way, so this is the total because every carbon need to make 4 bonds. So this is actually CH3, CH2, CH2, CH3, and it is butane. Okay. But if I wrote it like this way, yeah, like this way. So what does this means? This means that this carbon and this carbon are doubly bonded, and this carbon is single. So you can make single, then you will go to this carbon, then you will go to this carbon, but this carbon and this carbon is doubly bonded. And now you will come to this, this is single bond. Okay. Now you have to place the hydrogen accordingly. It has one single bond, the remaining are three. So you have to mention here three. Got it?
Yes, sir.
Got it? And
Yes, sir.
similarly, you have to mention here, and you have to mention here, you have to mention here, you have to mention, you have to mention here. All are making four bonds. Okay, please make this structure, please.
Okay.
You done this one? You noted?
No, sir. I'm still there.
Noted down, please.
Done, sir.
Okay. Okay. If I ask you that what is the hybridization of this carbon and this carbon? So you will check that this carbon is actually one, two, three, four single bond it is making. So it will be S, one S and P3. So total four. Okay, PR3 and one is S, so four. Okay, you understood? Got it?
Yes. Yes, sir.
And this carbon is one single bond, one single bond, one single bond. It is not counted because it is pi bond. It is sigma. This is sigma and this is sigma. So single bond is known as sigma bond. So here it is three bonds, three single bonds. So it is sp2, not sp3. It is sp2. You understood? It is
Yes, sir.
sp2. Okay. This one,
Yes.
this one,
It's 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 just SP.
this one would be sp2 again. Again, one, two, three, sp2. So if a carbon is making double bond, then its hybridization changes to sp2. And if it is making all single bond, then it is sp3. Okay. Got it?
Yes, sir.
Now
Yes, sir.
you know that this is sp3. This is sp3. So if I remove this hydrogen and if I place this 1x here, 1x here, okay? If I place it 1x here, okay? Up to here, this is carbon, 1x is here, okay? This is placing one hydrogen I have to remove. So this carbon is sp3. Got it? Got
Yes,
it?
sir.
And this carbon is sp2. Okay. So if I'm saying that what is allylic? What is allylic carbon or allylic halides? Allylic halides are those halides in which the halogen group is attached to an sp3 hydrocarbon, and which hydrocarbon is attached to a doubly bonded carbon. For example, here you see this carbon is sp3 carbon and this halogen group is attached to this one. Okay, this carbon is attached to this carbon, but this carbon from which it is bonded with two doubly bonded. So this is known as allylic halides. So note it down the definition of this one, please.
Okay. Done, sir.
Okay. So you noted this one? Okay.
Yes, sir.
Now you understood what is allylic halides?
Yes,
Okay.
sir.
Similarly, benzylic halides. Okay. Now moving to the next one is that we have next type of this one, and that is tertiary. And okay. Next type of halides is the types of halides we are just going to study. Okay. Next type of halides or haloalkanes, if I'm talking about here, is that in that one, a halogen's atom is bonded with the R. Means we will say that if the halogen atoms which with the carbon is bonded, you know that every time the halogen atom is directly bonded with the carbon, X is directly bonded with the carbon. Now check whether this carbon with which halogen group is attached, okay, how many carbon with it is attached directly. Okay. So if it is attached, R indicate the carbon chain. R indicate the carbon chain. R is an alkyl group, and it indicate group, and it indicate halogen group. Okay. It indicate carbon chain. Carbon chain. You understood? It indicate the
Yes, sir.
carbon chain. So if I'm talking about here is that, okay, so here we have R. So for example, let's suppose if I'm saying that this is the carbon chain, okay? This is the carbon chain, okay? And if it is X here, if it is X here, if it is X here, okay? X is an halogen group. Now you check that this is the main carbon which with halogen group is attached. This is the main carbon with which halogen group is attached. Okay. Main carbon. Now you check that how many carbon this carbon is attached. Tell me. This carbon is attached with how many carbon? Tell me.
Um,
This carbon is attached with how many carbon?
One.
One. Don't say two. Okay. Because this carbon is attached with this one, not with this one. So only this carbon is attached. Okay. Now, if I took the another example, if I take this one, like this, okay, and this one is a chain. So now can you tell me that this is the halogen group and the main carbon with which it is attached is this carbon. Now can you tell me that how many carbon with which this carbon is attached?
Um,
This main carbon is attached with how many carbons?
Two.
Two. It is attached with two carbon. Okay. So it is one and this is one. Okay. So it is known as secondary. So if it is attached only with one carbon, okay, whether it can be a same chain or a different chain, okay, it is known as primary. If it is attached with two other carbon, it can be same or different. R dash indicates same. If they both are R dash, it means indicating that this is a different because this is two carbon chain and it is R dash. It is only one carbon chain. It is R. So R indicate the carbon chain. Okay, so one carbon chain will be there. One carbon chain will be there. Means at least this carbon is going to attach with this carbon chain with the carbon of this chain and with the carbon of this chain. So this is two carbons. So this halogen group is attached with this carbon and this carbon is attached with other two carbons. So it is known as secondary. And similarly, if we have like we have CH3X here and this is C and C here. So it is known as tertiary. There should not be any confusion because it is very important that you must know. Okay, got it?
Yes,
Okay,
sir.
so just make this one. Alkyl halides, haloalkanes noted down and just draw this one only this portion that we have written primary, secondary, and tertiary respectively. Don't make as a whole everything. Don't write it as just
Yes,
write
sir.
this one.
Done, sir.
Okay, just benzylic halides are those that are going to have the benzene. Okay, they are known as benzylic halides. So if I took this one also, it help you to understand this concept. What is benzylic halide? So they are those that are containing the benzene ring. Okay, that those they are containing the benzene rings. Benzene ring means C6H2S, I mean C6H6. That ring that we have done this. So like here, this is the benzene ring. So if I'm saying those compound in which the halogen atom is bonded to an sp3 hybridized carbon attached to an aromatic ring. Now you have to keep in mind that benzyl halides are those which are containing the second carbon. The first carbon should not be attached with the carbon. For example, if this benzene ring is attached directly, okay, if I'm saying that this is the benzene ring, okay, and if it is attached with this one, halogen group, then it is haloarenes, simple haloarenes, okay, but okay, because it is directly, because this is the main carbon and this is attached with the halogen. But if I'm saying that this benzene ring, okay, this is the benzene ring, and this benzene ring, in this benzene ring, we have another carbon here, okay, another carbon which is having single bond, not double bond here, okay, and this we are attaching another halogen group, okay. Now you check that this carbon is sp3 carbon, sp3, because this has make one single bond here, one hydrogen here, one hydrogen here. We don't mention the hydrogen, okay. So here we'll check that this carbon is making four single bonds, so it is sp3 hydrogen, and this all the carbons of benzene ring are sp2 hybridized. All the carbon of benzene ring are sp2 hybridized. Why? Why it sp2? Because they are making double and then one single. So you'll check that this is how all carbons are bonded in the benzene ring. Okay. So you can check one, two, three single bonds. One, two, and three. Three single bonds. Three single bond means sp2. One, two, three. Three single bond. It is double bond is will not be counted. Again, single bond, then we will have this carbon, this will be bonded with hydrogen, okay. So this carbon is making three single bonds, one, two, three. So in benzene every carbon is making three single bonds, so every carbon is sp2 hybridized, okay. You understood? Got
Yes,
it?
sir.
Now these compounds in which a halogen atom is bonded with sp2 hybridized carbon atom attached to an aromatic ring. So note this one. And similarly, if this carbon is attached with one more carbon instead of hydrogen, so it will be 2 degree, 2 degree. If it is bounded with, when this carbon is bonded with 1, 2, and 3. Okay, so it will be 3 degree, 2 degree, 3 degree.
Yes, sir.
Done?
No, sir.
Done. Only made the structures and not the small definitions. In short, okay?
Okay.
Don't try to speak and everything. Done? Noted?
Yes, sir.
Now moving to the next part here is phenolic halide and the aryl halides. What is vinylic halides? Vinylic halides are those halides in which vinylic and means allylic. We'll say here that they are very similar to each other. There is a alkyl, okay, and this one, allylic halides and vinylic halides. There is a difference, okay. In the allylic halides, okay, you check here that in the it is an allylic means they will say that carbon is bonded with the this carbon is bonded with the sp2 hybridize or double bond means the halogen is attached with sp3 and which is further bonded with double bond carbon atom. Here this is a single bond. This is carbon. Here you check this is a carbon, but it is not a benzene ring. You can check it. This is not a benzene ring. This is having only single bond, double bond here. Not having every one double bond. Here should not be, here should be, but it is not having. So it is carbon, okay, and it is double bond. So this carbon with which halogen is attached, it is bonded with double bond carbon atom. It is bonded with double bond carbon atom. So we'll say that it is an allylic carbon. Okay. Now, or allylic halides. Now, talking to this one is that what is the difference between allylic and the vinylic halides? Here, this compound in which the halogen atom is bonded to sp2 hybridized carbon atom means here directly the halogen group is attached with the sp2 means directly double bonded carbon atom, not to the here in this one the carbon atom is bonded with the with this single bond. You can check it. You can check it like this way. I have given you example that this is the X and this X is attached with the carbon atom which is bonding, which is making single bonds. But instead of this one, if I make the if I attach this one with the double bond, for example, C double bond, okay, okay, C
yes,
here, and if I attach the X here, so this carbon with which halogen is grouped, it is bounded with double bond. So this is known as vinylic acid. Okay. So the carbon with the halogen atom is bonded with sp2 hybridized carbon atom is known as, or double bonded carbon atom is known as vinylic halide. And what is aryl halides here? In the aryl halides, what is the difference? That in this the carbon atom is directly attached, sorry, halogen group is directly attached to the benzene ring, to the benzene ring. And in the previous one, you can check it. What is the difference between aryl halides and the benzyl halide? In the benzylic halide, the carbon is the halogen group is not directly bonded to the main benzene ring. It is bonded with, it is not bonded like this way. This halogen is not bonded. Here we are going to have one more carbon, and with this carbon, with this carbon, with this carbon, the halogen group is attached. Okay. So this halogen with which the carbon is attached, it is not directly attached with the benzene ring. But in this case, in the aryl halides, you will check it. The main carbon with which this halogen group is attached, it is of the benzene ring. Okay. So note
yes,
this one in short. Okay. Write down the definition also because it is already short. In short. Okay.
okay. Done, sir.
Done. Uh,
Yes.
so in the next class today, Thameem, we have